In lesson 6.4, you will use inverse functions. In our first example, we're going to find an equation for the inverse of the relation y equals negative 3x plus 6. To do that, all we have to do is switch our variables x and y and solve for y. So subtracting 6 from both sides, we get our y term alone, and then we need to divide every term by negative 3 to get just y. So 1y is equal to negative 1/3 x plus 2. And this is the inverse of the relation or equation that we started with. We can prove that two functions are inverses of one another by using function composition. If we can show that f of g of x is equal to g of f of x, and that they both simplify to x, then we've proven that two functions are inverses of one another. So we'll start here in number 2 and first find f of g of x. So we're starting with f, which in problem 2 here is 1/3 times x minus 1, and in f we're going to put g. G is 3x plus 3. We'll distribute and add like terms to simplify. 1/3 times 3x is x, and 1/3 times 3 is 1. Positive 1 and negative 1 are 0, so this composition does simplify to just x. But in our proof, we have to also show that g of f of x is equal to x. So now we'll start with g, which is 3 times x plus 3, and in g we'll put f, which is 1/3 x minus 1. We'll distribute and add like terms again. 3 times 1/3 x is 1x, and 3 times negative 1 is negative 3. Negative 3 and positive 3 are 0, so again we're just left with x. So we've proven that function composition shows that those two functions, f and g, are inverses of one another. In this first problem, a model for a telephone bill is t equals 0.05 m plus 29.95, where t is total bill and m is minutes used. We want to find the inverse of this model and then use it. So I'll take the model, and this time we don't switch the variables because m represents minutes and t represents total time. All we do is solve for m. We just solve for the other variable. So I'll start by subtracting 29.95 from both sides to get the m term alone, and then undoing the multiplication and dividing by 0.05 on both sides to get m alone. So m is equal to t minus 29.95 over 0.05. This is the inverse of the model that we started with. Now we want to use the inverse to find the number of minutes that were used when the total bill was $54.15. So we'll substitute that total cost in for t, and we'll simplify to solve for m. So subtracting in the numerator, I'm going to get 24.20, and dividing 24.20 by 0.05, I can multiply top and bottom by 100 to get rid of those decimals. 5 goes into 2,420 484 times. So now we've found the number of minutes used. It's 484 minutes. Okay, in problem 2 on this page, we want to find the inverse of f. F of x is equal to 4x to the 4th power, and x is restricted to being greater than or equal to 0. So this is a function in x and y. So we will begin by switching our variables and then solving for y. So I'll start by dividing both sides by 4 get y to the fourth power alone. And then undoing that power by taking the fourth root of both sides of this equation. I'm taking an even root to get my variable alone, so I would get two solutions, but because we had the restriction in the beginning where x is greater than or equal to 0, and now x is y in the inverse, y is greater than or equal to 0, so I only need the positive value that I would get by taking an even root of both sides. So this is the inverse of f. In this problem, we want to find the inverse of f of x equals 2x squared minus 4, then graph f and its inverse in the same coordinate plane. So to find the inverse, again, this is an equation in x and y. So I'll start by switching x and y and then solve for y. So I'll add 4 to both sides to get our y term alone, and divide both sides by 2 to undo the multiplication. So y squared is equal to x plus 4 over 2. And now I need to undo the power by taking the square root of both sides. There's no restriction on our variable, so when I take an even root of y squared, the square root of y squared, I'll get just y, but I'll get two solutions, plus or minus the square root of x plus 4 over 2. Okay, and now to graph that original function f, it's a parabola, it's a quadratic equation, so I'm looking for a u-shape. I'm looking for a u-shape that opens up because our a value 2 is positive. So I want that vertex, and the x-coordinate of the vertex is negative b over 2a. Our b value is 0 because there's no x term, and I know that 0 divided by anything is 0. And when I put 0 in this equation for x, 0 squared is 0, 0 times 2 is 0, and 0 minus 4 is negative 4. Okay, so I'll graph 0, negative 4 on the coordinate plane. And I want to know how wide this parabola is, so I'm going to choose a couple values for x, negative 2 and 2, and I'll solve for y. So if I put negative 2 into our function, negative 2 to the second power is 4, and 4 times 2 is 8. 8 minus 4 is going to give me 4 for a y value. Put 2 into this function for x. 2 squared is 4. 4 times 2 is 8, and 8 minus 4 is 4 again. So I'll graph negative 2, 4 in the second quadrant, and I'll graph 2, 4 in the first quadrant. And I'll draw the u-shape that passes through those points. And now to graph its inverse, instead of making a table of values for the inverse of f, which is right here, all I have to do is take the table that I already made and switch the x and y values, because the inverse of a function, so I'll put in for x 4, negative 4, 4, and the x values in the original function become the y values in the inverse, so negative 2, 0, 2. So I'll be graphing 4, negative 2. I'll be graphing negative 4, 0, and 4, 2. And then drawing the u-shape that passes through those points. Okay, now when we have a function and its inverse graphed on the coordinate plane, they are going to be the reflection of one another about this slanted line y equals x. So that's another way to show that two equations, two relations, are inverses of one another if they are reflections of one another about that slanted line. If you fold the coordinate plane on that slanted line y equals x, those curves will coincide. We know that they're inverses of one another. In this last example, we want to consider the function f of x equals 3x to the 5th power minus 2 and determine whether the inverse of f is a function. Then find the inverse. So, to determine that, we will make a table of values and graph f. We know that it is odd degree, so it's going to have opposite behavior left and right. And we also know that it has a positive leading coefficient, so it's going to rise to the right. So I'll make a table of values to find this curve on the coordinate plane. I'll let x equal -2, -1, 0, 1, and 2. When I let x equal -2 in this function, -2 to the 5th power is -32. -32 times 3 minus 2 is going to give us -98. Now I'll let x equal -1. -1 to the 5th power is -1. -1 times 3 is -3. And -3 minus 2 is -5. When x is 0, this function has a value of -2. When x is 1, 1 to the 5th power is 1. 1 times 3 is 3. And 3 minus 2 is 1. When x is 2, 2 to the 5th power is positive 32. 32 times 3 minus 2 will give us 94. So I'll graph what values I can. -2, -98 is off my graph, but I know that it's low, so this curve is rising from the left. It's falling to the left, rising from the left. I'll graph -1, -5, 0, -2, 1, 1, and then I know that 294 is off my graph, but it shows that the curve is rising to the right and it fell to the left, just like we expected it to do. Okay, so this function passes a vertical line test. That shows that it's a function, and a vertical line passing through this curve intersects it in only one point at a time. It also passes a horizontal line test. A horizontal line that passes through this function is going to intersect it at only one point at a time. Because it does, that shows that the inverse of this function f is a function. So f inverse is a function. It passes a horizontal, or f passes a horizontal line test. Okay, and now we want to find the inverse. So since this is a function again in x and y, we can switch x and y and solve for y. So I'll add 2 to both sides and divide by 3. And then I'll take the 5th root of both sides to get just y. So I have y is equal to, and an odd root only has one solution. So I have y is equal to the 5th root of x plus 2 divided by 3. And now we've already shown that f inverse is a function, so I can use function notation on this inverse. And I'll write it as f inverse x, f inverse of x is equal to the 5th root of x plus 2 over 3. Include with your notes of this video guided practice problems 1 through 11 odd found on pages 439 to 442 of your textbook.